one or two questions. Good afternoon, children. Okay, so in this period we are going to solve linear programming problem with unbounded situation. Whenever the feasible region is unbounded, how to find the solution? That's what we are going to discuss. Okay, finding the solution in the unbounded case. Write the question. Solve find minimum value of z is equal to minimum value of z is equal to 3x plus 5y. Minimum value of z is equal to 3x plus 5y subject to the constraints x plus 3y greater than or equal to 3, x plus y greater than or equal to 2, x plus y greater than or equal to 2, comma x comma y greater than or equal to 0, x comma y greater than or equal to 0, and x comma y greater than or equal to 0. Okay, the question is find the minimum value of z is equal to 3x plus 5y subject to these conditions. Minimize. Okay, method and everything is same. Okay, so you first find out the solution set. You find the solution set x, y. When x is 0, y will be 1, isn't it? When y is 0, x is 3. Same way to consider the next one. X plus y is 2. When x is 0, we'll get y is 2. When y is 0, we'll get x as 2. And x comma y is greater than or equal to 0. Next, once you find the solution set, try to draw the graph. You can draw the graph. So when x is 0, y is 1. So when x is 0, y is 1, and when x is 3, y is 0. And this is the line given by x plus 3y is equal to 3. X plus 3y is equal to 3. Now we want to find the region, isn't it? When you find the region, look at the region. Is it below the line or above the line? If you substitute 0, 0, will it be satisfying? And you no, it is not satisfying, isn't it? 0 is greater than 3. It is not true. So it will be shading the line above this. Above the line. You have to shade the region above the line. Same way, take the next case. When x is 0, y is 2. When y is 0, x is 2. So here also we'll be getting a line like this. So we get x plus y equal to 2. X plus y equal to 2. You look at the region. Which is the region you have to select? Is it below the line or above the line? Which region you have to select, Nandana?
Above the line.
Above the line. So here also it is above the line. So when you shade it, so this is the region you will get, isn't it? And if you consider the first, so here you get one corner point, So you will be getting an unbounded region. You will get one unbounded region. Okay, up to this, is it okay? Write up to this and tell me up to this, is it okay? Shivani, Naureen, Rijas, Emmanuel. Ashwin, Srihari, Michael, Aryan, Ashwin, Nia, Michael, so up to that, is it okay? You completed drawing, okay, look at the region, is it bounded? No, isn't it? It is not bounded. But look at the question there. In the question what is asked? We are asked to find the minimum value of the function. Okay, we want to find the minimum value of the function. So now look at this from this region. Okay, we have 3 corner points here. Which are the 3 corner points you will get? Which are the corner points here? So this is the corner point 0, 2. And what about this point? And here this is another point. So this is 3, 0. So we have to solve and find out the corner points A, B, C. Find the corner points B. What is the point B? We have to solve these 2 equations. X plus 3y is equal to 3 and x plus y is equal to 2. Solve these 2 equations. When you solve this, we will get 2y is equal to 1. Therefore, y is equal to 1 by 2. If y is 1 by 2, what is x? X is x plus 3 by 2 is 3. Therefore, what is x? 3 minus 3 by 2, which is 3 by 2. Therefore, the solution is 3 by 2, 1 by 2. So the point B is 3 by 2, 1 by 2. This is the point. 3 by 2, 1 by 2. Okay. Now listen children. All of you sit straight. Sit straight. Keep your pen down. Sit straight. Listen. Look at the question. What is asked here? Is it maxima or minima? Atul? What is asked here? Whether we have to find the maximum value or minimum value? Minimum value. Now look at the shaded part. Is it bounded below or bounded above? Is it bounded below or bounded above? Is it bounded below? Look at the curve, look at the shaded part. Whether is it bounded below? Bounded below means whether there is boundary below the region or bounded above. Whether there is a boundary, the shaded part below, okay, in the lower part of the shaded region, is there a boundary or not? Look at here. This is the boundary here, isn't it? Okay, no line is going below this part. So that means it is bounded below. Is it clear? Is it bounded below? Okay, so here if you take any value above this, it will be more than these values. Is it clear? This is bounded below. Bounded below means what does it mean? Here there is a boundary. If you take if you take a solution, we are not getting the solution below this line. Below this part, okay, below this line, we are not getting a solution. All the solutions lie above this. So we call such regions as bounded below. Okay, now if it is bounded below, surely we will get the minimum, but we will not get the maximum. Why we are not be getting the maximum? Why? Why we will not be getting maximum here? Hi, Sania? Yes. All the points above this will be satisfying. So can we say this is the maximum point? We can't fix it, isn't it? If I fix a point here, someone will be giving another point here. So like this we go on, it goes on endless. So when it is bounded below, we will be able to find the minimum. Maximum sometimes only we will get. So here corner points are there. First you substitute it in the table. You substitute in the region. Objective function. Corner points, and the objective function is z is equal to 3x plus 5y. Substitute here. What are the points here? 0, 2, 3 by 2, 1 by 2, and the next point is 3, 0. Okay, now find out the value here. 0, 2. So when you put 0, 2, we will get it is 10, isn't it? And when we put 3 by 2, 1 by 2, so we'll get 9 by 2 plus 5 by 2, 14 by 2, which is 7. And here we will get 9. So which is the minimum value here? Which is the minimum value? Minimum value is 7. So here, although it is bounded, we will get the minimum value. Minimum value is 7. And it occurs at 3 by 2, 1 by 2. It occurs at 3 by 2, 1 by 2. Okay, why we are getting a minimum value here, children? Why we get minimum value here? Because it is bounded below. Okay, we can find out the least value from that. Okay, it is based on the graph. From the graphical part only we can see. Suppose your graph is like this. Imagine, suppose your graph, when you draw the graph, a graph is coming like this. Okay. A graph shaded part is coming above this. Now will you be getting a maximum here? Will you be getting a maximum? Will you be getting a maximum in this? No. We can't say which is the maximum and which is the minimum. Okay. Similarly, suppose a graph, okay, here we can say what is the minimum because it is not lying below this. Suppose it goes on like this. Suppose one line lies like this, another line is going on like this. So, and suppose the region is coming like this. So, can we forget maximum or minimum? The region is coming like this. Okay, this is one line, this is another line, and it goes on like this. So, there will be getting maximum or minimum. Okay, so there we will be using another method. Okay, whenever we get unbounded, okay, if it is bounded below, bounded below means lower boundary is given means we can find out minimum. But we have to find maximum means some cases only the maximum will exist, in some cases maximum will not exist. Okay, same way whenever it is bounded, okay, in some situations we will not be getting neither maximum nor minimum. Okay, so in the previous question we got minimum because it is bounded below. Once we draw the graph, from the graph only we will be able to understand whether maximum is there or minimum is there. Okay, now let us do another question and then we can discuss about whether maximum is there or not. Write the question. maximize z is equal to minus x plus 2y. Maximize z is equal to minus x plus 2y subject to the constraints x greater than or equal to 3, x plus y greater than or equal to 5, x plus 2y greater than or equal to 6, y greater than or equal to 0. Y greater than or equal to 0. Okay, the method is same. First find the solution set. Here x is greater than or equal to 3 means all the time x value will be, you can consider x is 3, isn't it? X value will be always 3, whatever may be the value of y. Now consider the next case, x plus y is equal to 5. X and y, when x is 0, y is 5, when y is 0, x is 5. Now consider the next case, x plus 2y is greater than or equal to 6. When x is 0, y is 3, when y is 0, x is 6. Okay, so we get the solution set. Once you get the solution set, try to draw the graph of this. So what is the first case? X is 3, whatever may be the value of y, y is 0, x is 3, y is 0. So we will be getting a line parallel to x, y axis. X is equal to 3 means it is a line parallel to y axis. So this is the line, x is equal to 3. Yes, Achyut?
Ma'am, what did we do for y is greater than or equal to 0?
Y is greater than or equal to 0 means which one? First quadrant, isn't it? This is the quadrant. First one, y value means this positive axis of y. Okay? When we take both the axis, x axis and y axis, here x is greater than 0. If you take this one, y is greater than 0. What about this? If you take this line, x will be less than 0. Here it is, y is less than 0. Is it okay, Achyut? So y is greater than 0 means only these two quadrants you will get. Usually when it is given x greater than 0 and y greater than 0 means it will be coming in the first quadrant. Here instead of giving x greater than 0, it is given x is greater than 3. That means only this part you have to consider. Okay? Is it okay? Is it? Yes? Where is Achyut? Achyut, he left. Yes. Achyut, is it okay? What about the others, Aryan? Start drawing the graph. Now look at the next one. What about the next solution set? When x is 0, y is 5. Okay, when x is 0, y is 5. So when x is 0, y is 5, and when x is 5, y is 0. So when you join these two, you will be getting a line like this. This is the line x plus y is equal to 5. Now what is given here? You check whether it is satisfying. X plus y, the equation given is here is x plus y is equal to 5. And what is the condition? X plus y greater than or equal to 5. So when you substitute 0, 0, will it be satisfying? X plus y greater than or equal to 5. When you put 0, 0, 0 is greater than 5. Is it correct, Shivani? Whether 0 is greater than 5? Is it 0 greater than 5, Shivani? Yes? 0 is it greater than 5? No, isn't it? So it will be above this line. Again here, above this one. Now take the next line. What about the next line? When x is 0, y is 3. When x is 0, y is 3. So when x is 0, y value is 3. And when x is 6, y value is 0. So again when you join this, this is the line. This is the line given by x plus y, x plus 2y equal to 6. X plus 2y is equal to 6. Here also we get the condition x plus 2y greater than or equal to 6. When you substitute 0, 0, 0 plus 0 is greater than or equal to 6. No, it is not satisfying. That means above this line. You have to find a point above this line. So which is the region? Which is the region then? If you select the region will be coming like this, isn't it? It should be greater than. It will be greater than 3. So, and coming like this. So the region will be like this. Look at here. It is unbounded. It is an unbounded region. It is an unbounded region. And here also we get the corner points. Which are the corner points you will get here? Here, this is one point. Okay. I mark it with red. I name this as A. This is another point B. Here is another point C. A, B and C. C is the point 6, 0. A is given by, we have to solve the two lines. Which are the two lines intersecting to get the point A? Look at the lines. Which are the two lines intersecting there? X is equal to 3 is one line and the other line is given by x plus y is equal to 5. So we get y is equal to 2. So this point will be 3, 2. So this is the point 3, 2. A is the point 3, 2. Similarly, find out B. B is the point got by intersection of the lines x plus y equal to 5 and x plus 2y equal to 6. So when you subtract this, we get negative y is equal to negative 1, therefore y is 1. If y is 1, x will be 4. Therefore the point B is 4, 1. So complete up to this solving, we are finding the point of intersections. We find the corner points. By solving, we find out the corner points. Okay. Okay, complete up to that. Okay, in the meantime, I'll mark the attendance. That one we'll be doing it in the next period. Okay. Okay, now listen children, listen. So now once we draw the graph, we are getting a region which is unbounded. The question is, find the maximum value. Look at the region, is it bounded above? Is there any boundary on the top? No, isn't it? It is just bounded below. Actually this region is bounded below. So we want to find whether is there any solution, is there any maximum value or not. So again what you have to do, like the previous questions and all, we substitute these values in the objective function. Objective function. You construct the table. Draw the table and find the objective. How many values are there? We get 3, 2. A is 3, 2. B is 4, 1. And C is 6, 0. Substitute in the value. Substitute this in the function. Z is equal to, what is the function here? Maximize. Z is equal to minus x plus 2y. So substitute here and find out the corner values, corner points. After finding the corner points, substitute there and find out which one is the maximum. When you put 3 and 2, minus 3 plus 4 will get 1. You put 4, 1, minus 4 plus 2, so you will get minus 2. Children, please check it, okay? Sometimes, okay, don't write it as such from the board. You check it and write it. Is it correct? You write all these things. These are the values we get. Our aim is to find maximum. So once we draw the table, from here we can understand which is the maximum value. Which is the maximum value here? Gauri, give the maximum value, Gauri. From 1, okay. So we get 1 is the maximum. Here we get 1 is the maximum. Okay, so we get 1 as maximum. But it is bounded below, it is not bounded above. So we have to confirm it. We have to confirm whether that is the maximum or not. Okay, listen, this is the important point, children. Now what we will do, we will substitute it. We will equate that function, the objective function, to 1. We equate the objective function to the maximum value over there. And you find the solution set. Find the solution set. X, y. Okay, when x is 0, what is the value? Y is 1 by 2, isn't it? When y is 0, x is minus 1. Okay? Is it okay? Up to this, is it okay? Now don't write, first listen. Listen children, don't write. We are finding the maximum value from the table. Okay? Because the graph, when we look into the graph, we understand that that region is not bounded above, it is bounded below. So is there a maximum value or not? For that, what we do, if it is minimum, you can answer it easily. Okay, if the question is minimum, we can select the minimum value there because it will not be going below that. We can select the minimum. But here maximum, we can't select it. So we select it and after that you have to test it, is it possible or not. For that what we do, we select the maximum value and we equate it to the objective function. And we find the solution set. Now draw this graph. Draw this graph. Okay, when x is 0, y is 1 by 2. When x is 0, y is 1 by 2 means this is a point. And when x is minus 1, y is 0. So when x is minus 1, y is 0. So x is minus 1. Now draw the graph. Listen children. When I draw the graph, you check whether the graph is passing through the shaded part. Is it passing through the shaded part? Is or no? Whether the line is passing through the shaded part? Yes, isn't it? That means this line has some common point in the max region. This line is having some common point in this region. That means we will be, okay, that means the given function has no maximum. We can find some more maximum value there. We will be getting another maximum value there. So here it is not bounded. When it is not bounded, what you can do? We equate that one to 1. We equate the maximum value from the corner points to the objective function. Try to, okay, now once you equate it, you draw the graph. Once we draw the graph, check whether the line is having common point with the unbounded region. If the line is having common point with the unbounded region, then there is no maxima. Why we are saying no maxima here? Because if the line is having common point, so we can find some maximum point. It goes on infinitely. So it has no maximum point, so we will not be able to find the maximum value. So the given function has no maxima. Rijas, is it okay? Is it clear? Diya, is it okay?
Yes, ma'am.
Why we say here there is no maximum? When we draw the line of the objective functions equating to the maximum value, we get some points common. If the point is not common, then we can take this is the maximum value. Okay? But here we get the point. The line passes through the region, unbounded region. It passes through the shaded part. That means it has no maxima. The given function has no maximum value. Z has no maximum value. But for the same question, if it is minimum, you can answer. Which is the minimum value here? Nandana? Minimum value?
-6.
-6. Okay, this for this graph you can find minimum, but there is no maximum because the line has some points common with the unbounded region. So there is no maximum. Okay? Is it okay, children?
Ma'am,
Yes.
so what should we write as the conclusion?
So you can say the given line. Okay, the line, that means the maximum value. Okay, when we equate the objective function to the maximum value, the region has common points with the line. Therefore, it has no maxima. Okay, this is one more question I want to discuss. That is from your textbook. It is a solved example question. It's an example question. So take the text. Okay, first you listen. Afterwards, you can go through the textbook. Okay, that we'll be able to discuss it completely. I don't know. Anyhow, we can start with that. One more period we have. That time we will continue with this. Okay, before that, look at this, children. These are the two theorems we use. Two theorems we use for solving. Okay, look at the theorem 1. What is given? Suppose R be a feasible region. What is given here? Convex polygon. If it is a convex polygon, then okay, for a linear programming problem, and let z is equal to ax plus by is the objective function. Then z has a optimal value where the variables x and y are subject to constraints described by inequalities, and this optimal value occurs at the corner point. If it is convex polygon, means it is bounded. Okay. Now look at the next case. Let R be a feasible region for a linear programming problem, and let Z is equal to AX plus BY be the objective function. If R is unbounded, then the objective function, okay, if R is bounded, then the objective function has both maxima and minima. Look at the remark. If R is unbounded, then the maximum or minimum value of the function may not exist. If it exists, it must occur at a corner point. If it exists, whether maxima or minima is there, means it will be occurring at one of the corner points. Now, you have one example here. How to find the solution of an unbounded region. That is what we want to discuss. Okay, just go through it, understand it. Sometimes if it is asked, be ready to answer it. Here also it is a bounded region. Look at this question. Example 4. Okay, example 4. Determine graphically the minimum value of the function. Okay, write this question. All of you write this question. Okay, we can solve and understand. Okay, write this question. Determine graphically the minimum value of the objective function. Z is equal to minus 50x plus 20y, minus 50x plus 20y, subject to the constraints, 2x minus y greater than or equal to minus 5, 2x minus y greater than or equal to minus 5. Second one, 3x plus y greater than or equal to 3, 3x plus y greater than or equal to 3, 2x minus 3y less than or equal to 12, 2x minus 3y less than or equal to 12, x greater than or equal to 0, y greater than or equal to 0. X greater than or equal to 0, y greater than or equal to 0. Okay. So do one thing, first draw the find the solution set and all. Find the solution set and draw the graph and check whether you are getting a graph like this. Is it bounded or unbounded? Start doing this part. Okay, try to draw the graph. Okay. We'll be discussing that one. Okay, that is an example question from your textbook. It's an example for unbounded region. Example 4 from your textbook. Write the question and find out the solution set and draw the graph. Okay, and we'll be discussing this one in the next period. So complete up to the graph. Okay, and next period get ready for the test paper. From which chapter? Which chapter, Aryan? Relations and functions. Learn the definitions and all, go through. Okay, thank you. Thank you, children.
Thank you.